Hello everyone, today we're going to be taking a look at creating a real-time chess game using Rails 7 and Action Cable. I'm going to go ahead and challenge John to a game here as a random choice for our starting position. So we can either be white or black. I'm going to click random. Looks like we got white that time. Now I don't have real time on the home page here, but you can click continue and you can see John can't do anything while Dean can. If Dean moves, now John can do something, but Dean can't. If you take a look, you can see that the FEN code down here is updated in real time. The PGN is updated in real time. And hopefully as I continue to make some questionable moves, maybe we can get something a little bit like this. And then hopefully we can do this. And then, I don't know, like this. There we go. That works. A little bit confusing doing that from both perspectives, but here you go. So you can see here, checkmate, white wins and black loses. We can now grab this FEN code. I mean, you could have grabbed this at any point, but you can come over to some website like chess.com or some other chess engine. You can go to learn and analysis. You can click set up a position. And what you can do from here is, let me scroll back out. You can paste in this FEN code and you get the position that that code was at. So this is a good way to jump to a specific position. But what happens if you want to see how the overall game worked? Because you can't right here. Well, that's where the PGN comes in. So by pasting in a PGN, you then gain the ability to move back through time, move forward through time, and you can even see the chess eval bar as this happens. You could see this was like a huge blunder because black can just take the queen here and there's not much white can do about it. But that's not what happened in the game. So you just come back here and then you go, okay, well here, and then I won and I feel good. I get the happy chemicals. So that's why we create both of those. They are updated in real time for both players, just like you would expect from a regular chess engine. Now, we're going to be covering a lot in this video, so I do apologize in advance because I'm going to be cruising through it. I will try and stop when we get to points where we need to, but I'm not going to be typing everything out. I'm going to be copying and pasting and then just, explaining what we're doing in the small functions we copy and paste. So it won't be too big that you can't just pause the video, but it will not be small enough for me to just, type everything. So we're going to CD out of our demo. We're going to do a, let me just make sure we don't have anything. Okay, so we can do a Rails new video with a -J of ESBuild and a -C of Bootstrap. We can then do a and to CD into our video project. So we are going to be using, Chess.Js, which is our chess engine. This runs on the front end, which means there is some potential for cheating there. You do need to watch out for it, but this is just the thing that's going to tell us what moves are valid and invalid. We then have our Chessboard.js, which is just the thing we're going to be using for the actual chessboard. Those require jQuery. I do apologize, but what can you do? And we are going to be grabbing some assets from the chess speedrun, which had a bunch of images in it. So we are going to be copying and pasting these. Okay, so now that that's done, we are in our video project. I'm going to run a code dot to open up VS Code. I'm going to drag this over, but we are going to be spending quite a bit of time in our terminal here. So in our gem file, we need to add a couple gems, and by a couple, I mean actually quite a few. So the ones we want to add are going to be the Foreman gem, which has to come from GitHub. Now, you probably don't need this if you're a normal person, but I'm on Ruby 3.2 right now, and because of my poor decision making, Foreman doesn't work with the default Ruby 3.2. So we have to grab the latest version, which is the work in progress one off of the main branch at the Foreman GitHub repo. We then grab Devise and Faker, and the last one we're going to grab is simple_form. So once we have all of those, we can run a bundle command in our terminal. That should install all of them, and then we can go ahead and get this set up. To get started, we're going to do a Rails G Devise :install command. We then need to do a Rails G Devise user command. We can then do a Rails G simple_form :install space -- bootstrap. And then after we do that, we can now do a Rails G Devise views command that generates our views for us with the simple form stuff. Okay, so that's user accounts done. Next step is going to be our controllers. Let's do a Rails G controller pages home. Gives us our home page. Let's do a Rails G stimulus. This is going to be our chess controller. This is going to be our stimulus controller for our JavaScript. And then we need a Rails G channel, which which is going to be our game channel. So this is going to be our action cable channel. This allows us to communicate with our backend in real time using the action cable channel, similar to how Turbo works. Now that we have all of those, we can generate our migrations. This part's kind of a lot, but we need to do a Rails G scaffold for our game. Each game is going to have a state, a turn, a FEN, and a PGN, all of type string. Then we're going to have a white underscore player underscore ID of type integer and a black underscore player underscore ID of type integer. We can go ahead and run that. Now we need to generate a join table, which is going to just be an empty model. So we're going to say Rails G model for our playables. There we go. So our playables here gets created. Let's come over to our Explorer, our DB, our migrate, and this last migration, just because I didn't feel like typing this out. We want to do a t.belongs to for the user and for the game. Then we can do a null false with a foreign key of true. So that sets up our migrations for us. At this point, we can come up to our app, our models, and in here we can open up our user, our playable, and our game. So in our playable, this is probably the easiest one to set up. All we really want to do is make sure that we have a belongs to for both of these. So once we have that, we can come into, let's say, our user model. Inside of our user model, we need to do a has many for the playables and a has many through for the games. That's how we get many games in our user, is through that other model. We can then do something like this. Let me get rid of these comments. That was just me getting GitHub Copilot to generate this for me, where we get the game in progress with the target user. So if we're playing any games with John, we want to see what those games are. So we call games.where. The ID is the target underscore user.games, and where the state is in progress. So we can go ahead and we can save that. Now we just mentioned state in progress, so you can already imagine there's going to be an enum involved in our game. Now in here we have a couple things. The first thing is we have the playables and we have the users through the playables. We then have two sets of enums. One's for the state, which contains our in progress, checkmate, and draw, and these do match up with our Chess.Js state. That's why they are written like that. It's not really great, but it's just returning strings and stuff. And then we have two before creates for setting the FEN and setting the PGN to their initial values. For the FEN, we just do def set FEN. FEN. And then in here, we need to first grab the abbreviation for the turn. So if it's the white player's turn, return W, else return B. And then for the self.fen, it's pretty ugly, but because the FEN is just a magic string, we need to insert this W or B at the key location, which is right here, which tells it that it is either the white or the black player's turn at this point in time. Now, if you thought that was ugly, wait until you see the initial PGN. To get this one to work, for some strange reason, I'm sure it's a quirk of Ruby that I'm not entirely familiar with, I had to paste in this initial string. Again, video code will be in the video description in the GitHub repository. But I had to paste in this ugly string here and tab it all the way over to the wall, otherwise it had a leading space. So yeah, that was a fun time figuring out what was wrong there. And then the last step is to do our def orientation, where we just check if we are the white player. If we are, return white, else return black. And this is used to, let me just comment this, used to rotate board for black player. So if you're playing as the black pieces, it rotates the board around so you see it from black's POV. Okay, so that's it for our game. The only other thing is maybe you want your playables to be like dependent destroy, so that if you try to delete a game, they get deleted with the game. That's something you might want to take a look at. So we'll just add that on. Okay, so that's it for our models. We're pretty much done in here. Let's come into our games controller. So in our controllers, games controller, there's a couple things we want to set up. First, we want to come down to our games param. We don't need most of this stuff. In fact, we don't need any of it. We're going to be passing in some custom parameters from our front end, which are going to be for the color that we would like to play as, either white, black, or random, and then the challenger ID, which will most likely be our current user, and the challengee ID, which will be the target user. To make sure this all works, we're just going to do a blanket before action to authenticate the user if we're on this page. We don't do anything in our index, in our show, in our new, or in our update, or our destroy. So all of these methods aren't touched, it's just the create. And how bad can that really be? Well, in the create, we have to start by calling assign colors. This comes from a include concern up here, which means we have to come into our app controllers, concerns, right click new file, and we're going to call this, what did I even call this? I don't remember. We're going to call this the color concerns. So we're going to right click new file, color concerns.rb. Inside of the color concerns.rb, we have to create a module and we have to extend active support concern. We then want to do a check to get colors. So get colors takes in a color choice. If the color choice is white, we return white. If it's black, we return black. Else we return a sample, which is just a random between black and white. This is used in our assign colors method right here, where we grab the color choice, and then if the color choice is white, we set up the parameters for the white player ID and the black player ID. Else we do the opposite by swapping which one's the challenger and which one's the challengee. Okay, so that's all of it for our concerns here. Let's come back to our games controller, and in our games controller, after we do all of that, we then need to create our @game, not using our game params, but using this set of state right here, where we take in the turn, which is going to be white by default, the state, which is going to be in progress, the white player ID, which is going to be that white player ID param we just made, and the black player ID, which is going to be that parameter. So that's where we're getting all of those from. Now in our respond to block down here, we have to create two playables. One is going to be, well, they're both going to be with the game of @game, but the user ID for the first one is going to be the challenger ID, and the user ID for the second one is going to be the challengee ID. Okay, so that's it for the controller. So at this point, we can close the users, close the playables, close the game, and close the controller, and close the gem file. So we're making pretty good progress here. Now the next step is going to be coming to our homepage. So in our views and our pages in our homepage, what do we actually have to do on the homepage? Well, on the homepage, we have a check for, let me just copy all of this. We have a check if we are the current user. If we're the current user, we tell them here's your email and a link to the logout button. We then render a partial called layout/players. If we're not logged in, we just link, or we just create those links for the person, right? So what is this layout/players? Let's come into layouts, right click new file, underscore players.html.erb. Inside of this players view right here, let me just make sure I open this. We are doing this. So we grab the @players.each. Where does that come from? Well, let's come up to our controllers and our pages controller. And inside of our pages controller, we want to make sure that we are grabbing all of the users that are not the current user. That's how we can loop through all of them and show who you can challenge to a game. We, of course, don't want to challenge ourselves to a game. We then get the games from the current user by checking if the user has any games in progress with the user we've looped through. So let's say this is John. We have 3 games in progress with him. Games now contains 3 games. It then says you are playing with John and you have 3 games that you're playing. We then loop through each of those 3 games with a link to continue the game by going to the game path. After we're done looping, we then render a partial for the challenge button where we pass in the user. This belongs inside of the games directory. So let's do underscore challenge underscore button.html.erb. And again, all of this code will be in the video description. But inside of this challenge button is where we start getting a little bit messy. So what we do in here is we create a container. We create a form with for a new game where we pass in a URL of the games path and a method of post because we're not actually visiting this page. We're just going to immediately redirect. We then have well, actually, we are kind of visiting the page, so maybe that's not right, but whatever. We then have a div. This div encompasses everything where we just create a row with a form group and a MB-5, which is just some Bootstrap styling that says, make it a row across the whole page, give it a margin bottom of 5 units, and make it a form group so it lays out nicely. We then create 2 hidden fields, one for the challenger ID, which is the current user, and one for the challengee, which is the user ID, which is of course passed in here while we're looping through all of the users. We then create a content tag where we just display the user's email. We then create a select tag, which just has the options for select of white, black, and random, which we can then pass to the back. We then give this a empty brace outside of this parentheses for the options for select, because this one doesn't actually style anything that we care about. We then do a comma and then we set another brace, and this one we can apply a class, which causes the drop down to look a bit more fancy. Finally, we create the form submit for the challenge. So after we do all of that and we come to the home page and we do a Rails db:/migrate, we can then create a seed file. So we come into our seeds. We of course had that migration or that faker gem that we added, so you know we're going to be using it. We create 3 user accounts, one for Dean at example.com, one for John Doe, and one for Jane Doe. And then we create 10 fake accounts using Faker, where we pass in a Faker internet email as the email. So that's just going to give us 10 random accounts just so we can see what it looks like. We can then do a Rails db:/migrate. And then after we migrate our database, we can do a bin/dev to start our server. If we go over to localhost port 3000 now, it'll tell us we're on Ruby on Rails, so we have to come into our config and our routes.rb, change this get to a root, this slash to a hash, and then come over to localhost port 3000 again, hit enter. It takes us here to the login page. Now I don't like how this looks, so let's come over to our layouts, our application.html.erb, do a .container.mb-5, hit tab, hit enter, hit alt down arrow key, and then hit Control S, and then that works. So now we're over here. This should actually be a margin top -5. There we go. We can now log in, and hopefully it takes us to a simple form. It does. We can now do a Dean at example.com with a password of password. Oops, password. It didn't seed our database. Okay, so let's come back here. Let's do a Rails db:/seed again. This time, hopefully it'll work, I guess. And then let's do a bin/dev. I'm going to copy my email here so I don't have to type it again. And then let's do a password. There we go. So now we can see what this looks like. We have John, we have Jane, and then we have a whole bunch of other people. But for this, we can click this drop down, and whatever we click will then get sent to the backend. So if we come over to John, we click on white, we click challenge. And if we scroll up here, we can see that we have a couple things inserted. First, we have the game with the state and all of the other stuff, including the FEN code. We then have a playables set and then another playables. So all of those things are already being generated for us. We now have our show page here. Okay, so from this point, what we have to do is actually create all of the chess logic. So that was the easy part. Now it's time for the hard part. So to make this work, we need to come into, first of all, our style sheets. In our assets, our style sheets, our application.scss, we need to copy and paste the same CSS that we used in the speedrun for chess. I'm just going to scroll through this real quick so you can see this. It just creates a bunch of ugly CSS for us that kind of works. And then the last thing we need is a custom bit of CSS just to make sure that our PGN doesn't scroll horizontally and it instead scrolls vertically. And this white space pre-wrap is the magic button here that makes it all work. Okay, so that's our application.css. Next, we have the images. So if you're not familiar, we use a whole bunch of images here. We need to get these from the speedrun GitHub repo. We can go to the SSH, copy this. You can also go to the repo that this project's in the video description where you're copying the code, hopefully, and clone this repo and then copy it the same way. You cd out of here, you do a git clone, you paste in whatever that repo is. You then hit enter. That should give you another directory in the directory you're in, which is the chess speedrun. From this point, you can do a cp-r into chess speedrun app assets images /star, and then you can copy this to your video and then your app assets images /. That should copy it in there. Now we can cd back into our video and do a bin/dev again to start our server, but we do need to do a yarn add for our chess.js and chessboard.js. Those will add both of those. I don't remember if we've done that already. Let's now do a bin/dev to start our server. Let's come over to our application right now. If we go to Google and we search for jQuery CDN, we can go to the jQuery CDN releases page, go to version 3, grab the minified version, click copy, paste it in here, give ourselves jQuery. We can now refresh the page, hit Control-Shift-I because we're going to need our console here, and we should be good to go. So that takes care of all of that. We have our pieces over here, of course. We can see them, hopefully, and we're good. So our assets can close, and I think our controllers can close now. Now it's time to get down to the nitty-gritty. So in our show page here, what we're doing is we are rendering our game, and in our game partial, if we full screen this, because we're not going to be seeing anything for a while. In our game partial, we can replace all of this with a DOM ID for the game, a turbo stream from the DOM ID for the game. This is actually, I don't even know if this is being used anymore. We can probably get rid of that. It was me testing out if we wanted to use turbo or not, but I don't think we do. So we can now do a row with a column-8, which is our game board, and a column-4, which is our PGN. So we have to create both of those. Let's right click on our games, new file, _board.html.erb. And then let's right click on here again, _pgn.html.erb. Now the PGN's easier, so we're gonna start in here. I'm gonna paste this in. And what we have here is a turbo frame tag with a DOM ID of game and then PGN, which is going to change this to be, I think, PGN _game _ and then whatever the ID is. Next, we have a h1 with our PGN, a div, and then we have a pre-tag in here that has our PGN inside of it. So it's in a class of PGN. That's the one that stops the horizontal overflow. Has an ID of DOM ID with the game and pre_PGN, which gives us pre_PGN _game _ID, which is a lot, I know, but it's the only way I can make this work. So then we have our game.pgn inside of here, and we can get rid of this console because we probably don't need it. So that's our game, or our PGN. Now let's take a look at our board. This thing is something else. So because we have all of those variables, we once again need to create a content tag for our stimulus controller. In our stimulus controller's data, we bind it to the controller, and then we pass in the game ID, the player ID, which is the current user, the FEN, which we get from the game. We get the turn from the game, but because the turn in Chess.Js uses the first letter only, we get the first letter of our turn, which is going to be like quote white. We get the first letter, it's going to be quote W. So we're going to use that ugly magic string W for this. We then get the orientation, which is why we created that method, which allows us to pass in this user, get the orientation. If we're black, it returns black. We check for this in our JS file, and then we rotate the board 180 degrees. So that takes care of our board. I'm just kidding. What we have to do now is we have to actually create the div with an ID of board in here. If you don't do this, you're going to have a very bad time. If you attach the ID to your content tag, you're also going to have a bad time because it's going to replace whatever's in this div with an ID of board. I had it in my content tag, which caused everything in here to get replaced. And what's in here is our state, which is another content tag, which just has a chess_target of state and the game state. And what else is in here is the FEN. So these are just two basic content tags where we're just setting targets, which we're going to use in our controller. Okay, so that takes care of our chessboard, takes care of our game and our PGN. So at this point, we've made quite a bit of progress. It's probably a good idea to stop our server, do a git add dot, git commit-m for init commit, just so we have this. Now let's do a bin/dev again, and let's get started, because now it's going to be JavaScript time and it's going to be WebSocket time, and neither one of those ever goes well the first time we try it. So let's hope that we can pull it off. We have our connect method here in our chess controller. Let's do a console.log for connected in here. And then let's do our static list of targets. And if you'll recall, our static list of targets included the FEN and the state. So we just put those in there. If we do this and then we refresh, we can see down here that we're printing out connected. So that's at least working. We can also see our state on the left and our PGN on the right. Those are also coming in cool. So what's next? Well, next we want to come into our channels and our game channel. In here, we highlight everything, hit Control X, Control S, because we don't need the game channel anymore. You can go ahead and close that. And then in our chess controller, we paste in our game channel at the top. We cut this out, so we leave the consumer. And then down here, we create a cable method where we return this consumer. And then in the connected, we just put in a console.log connected. The other thing we do is we grab the game channel right here, we hit enter, and then we replace it with this. So what this is instead of just having game channel, we pass in an object that has a channel of game channel and a game ID of this.gameID. This.gameID we get up here by calling a this.element.dataset game ID, which we passed in on our board. So we have our game ID right here. That's where we're getting it from. The reason why we do this is because this allows us to pass parameters back to our action cable channel. We covered this the other day in the sessions video on action cable. This allows us to come into our app, our channels, and our game channel. And while we're in here, we'll just set up the whole thing. But this allows us to come in here and do a stream from the game_params game_ID. This is how we section it off so that only a specific game sees the moves for that game. Next, we come down here, because we're going to be using this method in a minute here, we create a play move method where whenever we play a move in our chess controller here, it gets sent to that backend. Now we have to actually create this action cable subscription here. To do that, we just come down below our console log and we do a this.sub equals this.cable. This just allows us to keep a reference to this subscription if we ever want to use it. And that's why we start with the return right here. The next thing we do is we come above this sub. We're doing it a bit backwards. We do a this.play, and then at the bottom here, we do a this.gameOver. So we keep the game over check in pretty much redundant locations just to make sure we're not doing anything that we shouldn't be doing if the game's already over. Next, we come up here and we put the import for the chess and the import for the chessboard up here. And now we can dive into the monstrosity that is the gameplay logic loop. So for the actual gameplay logic, we come down here and we say, there's a whole bunch of setup that comes with this actually, which is kind of a nuisance, but because it's a JavaScript library, it's to be expected. We start by saying this.game equals a new chess game where we pass in the FEN, because remember the FEN is the starting position. We don't need to know the history of the initial setup to just create an initial setup here. We then get the PGN pre-tag, which is not inside of our stimulus controller. So we are just grabbing this with a document.getElement by ID sumi, and then we can have the ID prepended here, which is why we had that ugly DOM ID of pre_PGN_game_ID. We then grab the PGN as JSON, but it's not actually as JSON, it's just raw text. I forgot to rename this. Then we do a game load for the PGN. We then set the white square gray and the black square gray colors. We're going to be changing the colors as we hover over them for the highlighting. And then we say this.player is equal to this.element.dataset orientation, which was that orientation that flips it to black and white and has a letter of W or B in it to tell you which player you are. And then we're going to use that once again in our config block, which we covered in our speed run from last time. But in here, we now have a couple of extra options. So we have our position, which is set to the dataset FEN. We have our orientation, which we just set up there. But of course, this orientation is also just equal to this player. But I'm going to leave it like this. So we have that. We now can grab, or sorry, I think we use the player for something else. We have the OnDragStart, which calls a method, OnDrop, MouseSquare, MouseOverSquare, pretty self-explanatory on SnapEnd. It's just different events that'll happen with your chessboard. Finally, we have the chess theme, which needs to be /assets/pieces, and then we pass in the piece. Reason being, we're going to be at /game, so we can't just leave it as assets because then it'll try to do /game/assets. That won't work. Our assets aren't located there. After our entire config block is done, we can then do a this.board equals the chessboard, and then we can check if the game is over again because I just get really paranoid. Now I'm going to go through this. We're just going to copy these methods in the order they appear in, not necessarily the order we call them in, because some of them are just kind of ridiculous that we don't really care about. So this one just removes the gray squares for our move previews, which means we're going to have a method that takes in a square and then calls this. So we do this, we say GreySquares, it has a square. It's just selecting the ID and then the class inside of that ID. So it's inside of the board and then grabs the square inside the board. It then has the background, which is going to be the white square gray. It checks if it has the class. If it does, it sets the black square gray, and then it says set the background. This is used just to sort of deal with the move previews. The other thing that we have here is the OnDragStart. I'm going to start minimizing these as we go. But we have the OnDragStart. This is checking if the game is over. This is checking if the game's turn is not the current player's. If it's not, then we just return. And then it's just saying, make sure that it's not this side's turn. Now, this isn't actually there's really no logic here except for just checking what stuff can't happen almost. It's kind of like your safety net. The place that has a lot of logic is going to be our GameOver method, which is called all over the place. And the way this one works is we just check if this game is checkmate. And this is coming from our game object that we created earlier, which is right here, which is our Chess.Js game. So we do this logic check on the front end. You'd probably want to do most of the stuff on the back end and then just send it to the front end. But for the sake of this video, I thought this was good enough. We check if there's a winner. If there's a winner, we just say this.game.turn is equal to W. If it is, then set it to black, else it's white. Because the player that made the checkmate makes the move, and then it becomes the other player's turn. So it's the losing player's turn when they accept the checkmate. So then we have to say that the turn is the not losing player's turn. So that's why we're inverting it. We then set the state targets inner HTML to just say checkmate, the person won. And then we check if there's a draw. If there's a draw, we just set it to draw. That's it for our GameOver method. We are almost done at this point, I promise. I know it's been fast. You've probably had to pause a bunch of times. I do apologize. Next, we have our OnDrop. So this is where we call our RemoveGreySquares. So we've dropped the piece. We are now done previewing our potential moves because we've made our poor decision. We're ready to lose the game. Then we check whose turn it is. If it's not the current player's turn, then we just return because like they're trying to make a move when it's not their turn. That's kind of cringe. We then define a move and we try to make a move. This will throw an error if it is not like a legal move. So we create a move with this.game.move. It takes in an object of the from and the to and a promotion. Now this allows you to promote your pawns. Of course, if your pawn reaches the other side of the board, they can promote to either a minor piece or a queen. And the way that that works is, sure, you probably want the queen most of the time, but sometimes it is beneficial to under promote, which is either creating a knight, which is self-explanatory because it moves in a different way than the other pieces. But sometimes you can under promote to a bishop or a rook instead of a queen to avoid a stalemate. So you don't want to hard code this, but in this case, I've hard coded it just because I feel like we've already covered enough in this video. I got to draw the line somewhere. Otherwise, this is going to turn into an 8-hour thing. If this fails to work, it'll just console log that it was an illegal move. You can probably remove this. You don't really need to care about it. And then if we get down here, we just know that, if there's an undefined for the move, we didn't get a legal move. So we just return a snap back, which just moves the piece back to where it came from. It snaps it back. Okay, so that's it for the OnDrop. Next, we have the OnMouseoverSquare. So if we're mousing over a square, we check if it's our turn. We could, of course, not do this check if we wanted to. But then we check if there is if it's a legal move. Sorry, words are hard. And we do that by just passing in whatever the cool little documentation told us to. We then check if there are no moves available for the square. We exit. We highlight the square that we're mousing over by calling this.GreySquare. And then we highlight the possible moves for this piece. So if it's a knight, it shows you which way the knight moves. Maybe we can send that preview to, like, I don't know, one of the chess streamers. We can then do a OnMouseoutSquare, which is what happens when we leave the square we're previewing, which of course means we want to remove the gray square from there. We then want to create the game state, or check the game state, which is just checking, are we in a checkmate? If we are, return checkmate. If we're in a draw, return draw, else return in_progress, which is how we're setting the state in our game model. We'll call that enum with the ugly strings. That's why we have them, because it matches up with the game state. We then do our OnSnapEnd. If our snap ends and it's a legal move, we send the move. And then down here is where we actually do the sending of the logic to our stimulus channel. So this calls a this.subscription, which is why we stored it in a variable up here. So our cable subscription. We say this.subPerform. We want to perform a method, which is the playMove method. That's how you call a method in an action cable backend from your front end, is by using the perform and the method name, and then it takes in an object. We pass in the move, which we get from this.game.history, verbose of true, and we pop off the last one, which is going to be the last move that was just made, which is the one we want to make. We then pass back the FEN, the state, and the PGN. That comes back to our game channel. Our game channel in our play move now needs to handle this data, update our models, and return this data. So what does this look like? And if you can believe it, we are probably 2 or 3 steps away from being done. So we get our data, we say, find the game with our parameters. We check whose turn it should be. We know that if we are white, it should be black. If we are black, it should be white. We then say, let's convert this, the state to a enum. We then want to get our FEN, which we can just do by calling data and FEN. We then want to grab our PGN, which we can just do by getting our PGN. We can then update our game object by calling save. We can then change whose turn it is, which we probably should have done up here. We can say the game's turn is the new turn for our data, so we're passing back whose turn it is. And then down here we have our broadcast, where we do an action cable.server.broadcast to this channel up here, and then we pass back some data, and that'll work just fine. So this comes back to our chess controller, and then up here inside of our cable channel we have a received method. And this is where we do our final stop, hopefully, fingers crossed. And in here, we have to do a little bit of fancy magic. We're going to refactor our method signature, because right now it just has received and this parentheses and argument. What we want to do instead is to preserve the this from out here. When we call this.sub.perform, we can declare the method like this, which allows us to pass in our context, or to use our context. And then in here, we do a bunch of other stuff, which we'll just put in right here. So we say the board position is equal to the data.fen. We use the this.game.load to load our fen. We then say this.fen.innerHTML equals data.fen. I don't know if all of this is necessary. This is just how I got it working. Again, this is like, 8 or 9 hours in the day trying to figure this out. I do this in my free time, and there's not much free time, so I do apologize. There's not a lot of brain cells left when I'm done with these videos. We then do this.pgn_pre_tag, which is grabbing that PGN pre-tag that has our pre-formatted data inside of it. We set the text content to be this PGN that we got from our backend. Afterwards, we check if the game is over. We hit Control S and F11. We come over here, we hit Control R, we hit Control Shift I to see what's broken in our console. So it doesn't look like anything is necessarily broken, but we need to actually get this to render. Okay, so what I did was I copied my code from my notes, I pasted it in, I hit Control S, I refreshed it, it worked. I hit Control Z to undo it, hit Control S, and it's still working. So I think it might have been a caching issue, but if I restart my server real quick, we can just verify and see if this is working, assuming it wants to load, which it does. So we do have a working copy now, I believe. So it was just a weird caching issue. One other thing I do want to point out, maybe make sure this is a .. to make sure it's going into the consumer directory, because that's coming from our channels or something, but that should be fine. So I think if we hit Control-Shift-I, this should be working. Let me hit Control-Shift-N. Come over here, go to localhost port 3000, click login as john@doe.com, the password of password. Now we have 2 games here with Dean. I'm going to click on the second one. John is playing as black. Let's see if John can make a legal move. Doesn't look like it. If I hit Control-Shift-I, nothing's happening, so that's good. Let's come over to Dean's side of things. I'm going to move both of these so we get full screen. On Dean's side of things, I'm going to grab the E pawn, move it to E4. John's screen moved, our PGN updated. It looks like everything should be working. It looks just good. Let me grab Dean's and drag this off. You can see here we get the invalid move, but John still can't move, Dean can, so that's good. Let me do this. Let's go for a Scholar's Mate. John still doesn't know the buttons, if you can believe it. We're going to do this, and then John's going to choke it. And then we're going to use, I guess, let's maybe make sure that John doesn't walk away from this one. I almost messed it up. What we'll do is we'll say maybe John does something like this, right? And then we can grab this and do the checkmate. So that works. We can grab our our FEN code, and we can come over to chess.com. Sorry, it's a lot to do this and do a tutorial and play chess. If we come over to, and it's like 6 in the morning, I've been up all night. We can paste this in. This is working. Let's grab our PGN here and let's paste that in. Let me refresh first to make sure this is working. Let's click Setup Position, paste this in, click over here, and it looks like that's working. If we go back, we can go through the entire game. Cool. Okay, so that is all working. I will now go ahead and commit this to our GitHub repo. I'll do a Control-C. We'll hit F11. We can do a git add. Well, let's do a git status first to see what we changed. Git add dot, git commit -m, add Realtime Chess. And now we can come over to GitHub and commit this. So that's going to do it for this video. Hopefully this was interesting. It was definitely a lot of work to put together, so I hope you really liked it. Hopefully this was helpful, because this is probably one of the only times you're going to see a demo like this on YouTube until I do the next one, I guess. And hopefully I will see you in the next video. Thank you so much for watching.